Now we've got three amino acids here called the threonine, because again they're all related here. We've got threonine itself, glycine, serine, and alanine. So threonine, the main key word here is immune system. And I've started using this myself with my patients with immune. It's something to consider when a person has an infection. So you might want to put that down along with the things we've talked about in the last couple of modules. When people get an infection, a virus or a bacteria, to using amino acids as single, what are called free-form amino acids. So free-form means it's the single amino acid, just as the body would digest a protein and absorb them as single amino acids. So by the time they've been broken down by protease enzymes, we get single or free-form amino acids to be absorbed. So these, as a supplement in their own right, don't need any digestion because they're all digested, if you like, they're fully. So you tend to take any free-form amino acid at least 15 minutes before a meal. Ideally, breakfast is the best time to do this. So you take them 15 minutes on an empty stomach. Now, they used to always administer to suggest to get them across into the brain, particularly, and into the cells, to accompany it with fruit juice. And the best fruit juice there was apple juice. And we all thought it was perhaps at that time malic acid or maybe the sugar that did this. But in fact, now we've discovered it's the succinic acid which does it. So we put the succinic acid into the amino acid. So if you take it with that, then it says you happen to have it with apple juice, which is a bit sweet sometimes. But threonine is worthwhile considering, when people have got an infection coming on, because the quicker you can hit the infection and get that innate immune system to work rather than the adaptive, the better. So it promotes the growth of the thymus, which is involved, of course, with the immune cell differentiation. Rats supplemented with threonine show significant increases in their thymus weight. So it may be involved as we get older, we tend to get a thymus atrophy. The thymus sort of disappears. It's identified as protecting against mental instability. It helps with digestion and helps metabolize fats in the liver. It's useful in treating central nervous system studies. There have been studies that show that it may be involved in helping rebuild myelin. So important perhaps to consider with demyelinating disorders like MS. Glycine, as I said, is the simplest of all amino acids and one of the most abundant. It's derived from serine and threonine. Collagen contains every other molecule. It's glycine, something, glycine, something, glycine. So it's every third molecule is glycine. The other amino acids are protein and lysine, or their hydroxylated derivatives. It helps with storing energy and builds up glycogen levels. Glycine, along with taurine and GABA, is one of the major three inhibitory neurotransmitters, so it's a calmer down. It's involved in its own right with detoxification. So glycine is a substance, is an amino acid, which detoxifies primarily benzoic acid and benzoates, which are food preservers. So benzoic acid and benzoates are added to a lot of soft drinks and foods. Anything in a package may contain these. So they extend shelf life, but some people are very sensitive to benzoic acids and things. So it stimulates the production of glutathione because it's part of glycine, cysteine and glutamic acid. And it reduces the levels of uric acid. So you may put a line across there, clinically consider this with gout. So gout, I always do zinc and sodium bicarb to alkalize the system, zinc, and now you might want to add there clinically glycine to that as well. Serine, again, what we call a non-essential because it's made from threonine or glycine. It's involved with phospholipids, particularly phosphatidylserine, which is an important part of the phospholipid structure of brains, of nerves, particularly in the hippocampus and other areas of the brain. So the areas which are involved with memory and learning are particularly rich in phosphatidylserine. So therefore it may have a role, phosphatidylserine or serine, with Alzheimer's disease. Clinically, one thing I've learnt there from a migraine sufferer is you should never prescribe serine to a migraine patient. It brings the migraine on very fast. So just right there, do not use with migraine patients. I don't know whether anybody actually knows why that is, but migraine patients, it's almost a way to define whether you've got a patient with a true migraine is do they weaken to serine, because don't ever give it to them because they get a migraine extremely quickly. So obviously the muscle-wise they would weaken to serine. Alanine helps in hypoglycemia, which is low blood sugar levels. So it's good for people who get that drop in blood sugar. Can be converted quickly to usable form of fuel or glucose. Regulation of blood sugar levels in hypoglycemia and diabetes triggers the release of glucagon, which releases glucose from cells. It's largely concentrated in muscles, alanine. One of the most important amino acids released from muscles in forming energy. Transports nitrogen from muscles to the liver. We're now going to look at 3 amino acids which come together called the branch chain amino acids. BCAA, you come across these or you hear a lot of them, you see a lot of powders with these 3 amino acids in health stores, and a lot of people use it to lose body fat and gain body lean. These are the most important amino acids in muscle. So when your blood sugar level drops down, what happens is cortisol will come in, cortisol from the adrenal glands, to elevate blood sugar level. This happens a lot about 4 o'clock, 5 o'clock in the afternoon, when your blood sugar level drops because it's 3 hours since you've eaten and things. So it goes down, and then the adrenals produce cortisol, which mobilizes blood sugar level. And it does this through a process called gluconeogenesis, which we're going to look at in the next module. And in other words, it converts proteins or amino acids back up through the glycolysis pathway to produce glucose. So it's like a reverse process. So it uses amino acids as a source of energy to convert them into glucose. Okay, so it's a way the body continues to use fuel. When the blood sugar level drops, it increases that. Now, it's going to burn any amino acid that it can. Okay, so if your amino acid pool is low, in other words, the amino acids in the blood are low at that time, the biggest source of amino acids is the muscles. So it starts to strip the muscles. And this is why when people have cortisol, they tend to lose muscle, because it mobilizes the muscle, it breaks down the amino acids. So these are considered to be the richest ones, the easy picking for the body to work with cortisol. So this is why they're sometimes put together as a supplement for people who are exercising. And we'll talk about the time of that a little bit later on. So leucine, isoleucine, and valine. These are all, as we see, essential amino acids that you have to get from the diet. And they're the rich ones in the muscle. And these are the ones that tend to be needed to supplement when people exercise a lot and get injuries. So they protect the muscle during stress, as we'll see when you're doing high intensity training. It acts as a fuel for muscle building. They repair muscles and prevent the breakdown of muscles. And it enhances the energy and increases endurance. When deficient, a wearing out syndrome leads to decreased muscle mass. Constituents of many neuropeptides capable of producing calming and pain relieving effects, including enkephalins. Leucine itself helps to stimulate insulin. In muscle insulin, valine deficiency causes neurological defects. I've got one patient who really relies upon valine. Every time she comes off the valine, her neurological symptoms of weakness in one side of her body comes back. I don't know exactly how it works, but you know, if she takes it, she's much better. If she leaves it off, she's all right for a week or two, and then gradually the symptoms come back on. So low isoleucine can lead to muscle tremors, and maybe these are all decreased in liver diseases. We'll come back. The combination of these is involved also with sarcopenia. Sarcopenia is, as we get older, is a loss of muscle mass. So it's not just an atrophy from lack of use, like if you have a plaster cast, but sarcopenia is something that happens as we get older, that we actually lose muscle mass. So this is when people, you know, suddenly lose weight when they're in their 80s and things like that. And it's very, very difficult to ever get it back. What the French have found with studies, particularly in animals, is that by supplementing branched-chain amino acids, it helps to prevent sarcopenia. Maybe because older people don't eat enough muscle tissue, in other words, meat, because maybe they've lost their teeth and they find, or they live on their own and they don't eat so much meat, and then you don't get enough of the branched-chain amino acids in. And they found that the branched-chain amino acid ratio must be 2 of leucine to 1 of isoleucine and valine. So it's a 2-1-1 ratio. So it's the leucine which is the important one, or the greater abundance. If it's not that combination, don't use it certainly for protection. It has to be that combination really if you're going to use it. But we'll come back to how to supplement this and when during exercise in a minute. Right, lysine we mentioned briefly because it's sort of an antagonist or the opposite to arginine in many ways. This is one of the problems with using composites in any way, or multiple mixes of all the amino acids, say, because some of them have opposite effects. So you may find that a multiple amino acid doesn't produce a reaction in the body, but an amino acid on its own, tied in with the clinical thing, may produce a profound effect. Okay? So arginine and lysine are examples of this. And we'll see later on, some amino acids are positive and some are negative. Some are water-loving and some are water-hating. So they have opposite effects. So if you have a composite of all 20 amino acids, you may not get a reaction from the person, and because one is stimulating and one is inhibiting. Okay? Composites are really good general screeners, but they're not, nothing is ever finite because of this. So lysine is involved with the immune system. So proper growth and development in children. It's well known for fighting cold sores. So I'm not sure whether it does actually fight cold sores or it just inhibits arginine. But you shouldn't give arginine generally with, if a person's got a tendency towards a cold sore, herpes simplex. And I think arginine we talked earlier was in chocolate as well, wasn't it? There was another factor, was it stress? Stress built up arginine as well. So stress, chocolate, which is what people sometimes crave chocolate when they're under stress anyway, may be enough to bring out a herpes simplex rash, cold sore rash. It has a broad immune enhancing capacity, so again, along with threonine, might be something you consider in infections. It stimulates growth of the thymus, so it's good for the adaptive immune system, and it stimulates the T and B cells, again, part of the adaptive immune system. Lysine and arginine share a common transport system insofar that they're opposite. Lysine is sacrificed in stressful situations, psychological and mental stress. So lysine goes down, which proportionally puts arginine, the ratio arginine up when they're under stress. I think we talked about Christmas as being a stressful time. A lot of people who've got a bit of a tendency towards that get a rash after Christmas. The stress of Christmas and usually eating a lot of chocolate at the same time is a good recipe for if you've got a tendency towards cold sores. It has an antiviral effect by blocking the activity of arginine, which we said, which promotes the cell replication. Yeah, so again, as I said, along with threonine, think of lysine for immune system. So in herpes simplex virus, increase lysine foods and reduce foods higher in arginine, like chocolate. Foods high in arginine are beer, peanuts, almonds, walnuts, wheat, soybeans, sunflower seeds, and chocolate being probably the one we should put in first. Okay, lysine roles in the formation of collagen. So collagen is glycine that we talked about, and protein and lysine. It may have a role in, because the collagen is the most abundant protein in bone, so therefore it may have a role in the structure of causation of osteoporosis. Osteoporosis is interesting because really osteoporosis is not so much the decalcification of bone or demineralization of bone. It's actually the loss of collagen, the scaffolding that forms where the minerals attach to. So it's really a collagen disease. So collagen is built on these 3 amino acids, through a process which we'll introduce a little bit today. But really the demineralization is sort of secondary to the loss of the scaffolding, first of all. Studies suggest that lysine along with arginine make bone-building cells more active. So lysine helps absorb calcium and decreases the amount lost in the urine. It goes on, it's the main constituent of carnitine. And as we'll see a little bit later, carnitine is something which is involved with burning fats in the body. So when we mobilize fats, long-chain fatty acids, into simple fatty acids, easy, small-chain fatty acids, they have to get them into the mitochondria to burn. And to get them into the mitochondria, between the two mitochondrial membranes, it needs a carrier, and that carrier is called carnitine. So the carnitine carries it and is recycled, called the carnitine shuffle. So we'll see carnitine again a little bit later, but the main amino acid that makes carnitine is lysine. So it's responsible for converting fatty acids into energy. Now histidine goes on to make histamine. So histamine and histidine are different. Histamine is a decarboxylated, or is the removal of a hydrogen, of a carbon dioxide rather. But histidine itself is an essential amino acid. Low levels have been found in conditions like rheumatoid arthritis and problems with the drying out of the synovial fluids. It's been shown to have anti-inflammatory properties, which you'd expect because of rheumatoid arthritis. It has a regulation of growth and repair, so low levels can lead to slow regeneration of tissue. So worth considering with inflammatory, anything which is inflammation. So it may actually have an anti-inflammatory effect. Deficiency can lead to slow development in children. It will convert to histamine, which is an important immune system modulator. So we always think about histamine being a bad guy, but histamine actually keeps us awake. If we didn't have histamine, we fall asleep. And that's why if you take an antihistamine, you tend to be advised not to drive, because you're more likely to fall asleep. So histamine is something which is actually good, but like all things, if you have too much, it's a pro-inflammatory chemical then, and causes itching and swelling and things. But if you don't have enough histamine, you fall asleep. So it's an arousal stimulant. So it converts to histamine, which helps to regulate defense, because we need histamine to dilate the blood vessels to get healing response. Methionine counteracts the formation of histamine from histidine. So methionine coming in here. So we see that methionine and histamine are working in opposite sort of ways. So again, you might want to put down there a little tag. Methionine might be an natural antihistamine. You might want to just jot down here other natural antihistamines. Not that it's the histamine season at the moment, but it's always the histamine season somewhere around the world. And of course, here in November now, this is what I call the mushroom growing season. So there's a lot of molds and spores, and people can be allergic to that, and coughing and sneezing a lot. Okay, so to break down histamine through what's called the diamine oxidase pathway, we need vitamin C. So vitamin C helps us to actually break histamine down. It's not an antihistamine. Histamine is produced in special cells called mast cells, special white cells called mast cells. And if the membrane, the cell membranes, these becomes unstable, histamine leaks out and creates the problem. So the cell membrane stabilizers, as they're called, is vitamin E, zinc and magnesium. And one of the most powerful aids in that are bioflavonoids. So bioflavonoids are flavonoid compounds which are non-essential in the human body. So they're compounds which are usually in fruits and vegetables and things. They're not an essential nutrient. There's no pathway which uses them, but they are natural antihistamines. And the best ones there are hesperidin, which comes from the pith of grapefruits, and quercetin, which comes from the pith of oranges. So these are very bitter substances, but they're fantastic and natural antihistamines, particularly if you give it before the histamine reaction. So if somebody gets hay fever, let's say in May, they tend to get hay fever to a particular pollen or plant. And if you know when it comes on, say the first week or so of May, you start to take the hesperidin or quercetin, say mid-April, and then they don't get the reaction, so they stabilize. If they have got an allergic reaction, and then you give them the quantity to switch that allergic reaction off, which may be 1 or 2 capsules, and directly the symptoms start to come back again after a few hours or later in the day, you give them another dose. Okay? So you do that for 2 or 3 days, gradually then tailing off, and you switch the mechanism off or increase the stability of the mast cell membranes. Okay, so it's very, very effective. And it always seems to be around the time when children take exams. They start to develop hay fever. And if you've got high histamine in your brain, you really can't think. You know, if you ever get a cold and you get really congested, you can't think straight. And you can imagine then children taking very important exams like degrees or GCSEs, A-levels in this country, and you've got a histamine reaction. You know, so remember that vitamin C helps to break it down, so you can take a high dose of vitamin C, but the most important thing is to stabilize those membranes. So vitamin E, zinc, magnesium, and the bioflavonoids. Vitamin E is something we're finding increasingly showing up with people. We talked this in the last seminar, or 2 seminars ago now. Vitamin E is something which is getting less and less in oils, because the major source of vitamin E for us is our oils, is seed oils. And by the time you get the seed oil, the vitamin E has left, because the oils have been left in the light, maybe in light bottles and things, and the oil's gone rancid and there's no vitamin E left in there. So our sources of getting vitamin E within our foods are less and less these days. And if the oil goes rancid because it hasn't got the E, so do you. So you go rancid because you produce free radicals or reactive oxygen species in inflammatory process. And unless you've got the E to protect you, you go rancid as well. And we see that in the skin, the brain, all many different diseases and disorders. So that's histidine. So histamine itself from histidine is a neurotransmitter. It keeps us awake, as I say, as an arousal. It can improve sexual functioning. That's why the old way for impotence was a stinging nettle down below, and give a quick waft with the stinging nettle and you get a histamine response. So it can produce sexual functioning, it stimulates the secretion of pepsin, so it's a regulator of the production of pepsin through the hydrochloric acid. So it's like a regulator. Some people say it's like music in a shop or a lift. It's there, you sort of miss it if it's not there, but it actually doesn't really do very much, but it has an involvement with it. So histamine is produced from histidine by pyridoxal 5-phosphate. So it does tend to sort of regulate rather than actually stimulate. It's helpful in hypertension due to its vasodilation. So the one thing you get with histamine is redness, isn't it? And redness is a vasodilation of the blood vessels, often associated with itching and can be pain. So I think this is nearly our last, or towards our last group of the 20 amino acids, is phenylalanine, tryptophan, and tyrosine. So I talked about tyrosine going on to make dopamine and noradrenaline, tryptophan going on to make serotonin, and phenylalanine goes on to make tyrosine. So each one of these amino acids has a key word, and phenylalanine, the key word there is pain reliever. It helps, as we'll see, to produce endorphins. Tyrosine is the addiction fighter because it helps the body naturally to produce dopamine, which is what we get when we feel good. And if you feel good, you don't need to take cocaine or anything else. And tryptophan promotes sleep because it goes on to make serotonin, which then goes on to make melatonin. So tryptophan brings us up to feeling good. So there's an aromatic ring in the structure of these three amino acids. They're natural stimulants. Phenylalanine, there we are, that's the same. So phenylalanine is a constituent of numerous substances in the brain that affect mood, pain, memory, learning, and appetite. It blocks enkephalinase, the enzyme that breaks down endorphins and enkephalins. These are the things that relieve pain and make us feel good. So it helps to block the breakdown of those. Studies have shown that beneficial in certain arthritic and inflammatory conditions. It may curb cravings and is decreased by drinking caffeine. Interesting. Because you always think about caffeine being a stimulant, but maybe in here, if it decreases phenylalanine, it could go on to decrease the production of tyrosine and dopamine. It's a precursor to tyrosine dopamine, which is what, as I said, useful for depression as it raises noradrenaline and dopamine, of course. It converts to phenylethylamine, which triggers the release of endorphins. So that's phenylalanine. So tyrosine, which is derived from that, is a precursor to the thyroid hormone. So we looked at those in the last module. So tyrosine, when it has 4 atoms of iodine attached, is called thyroxine. If it has 3, it's called T3, triiodotyramine. So it's a precursor, the building block to thyroid hormones. It's a precursor to melanin. So it goes on through that enzyme we talked about last time called tyrosinase, or tyrogenase, as the Americans call it, which goes on to convert tyrosine into L-dopa to make melanin. It's a precursor of other neurotransmitters like noradrenaline and adrenaline, and it reduces symptoms of cravings in addiction because it stimulates dopamine, which is the feel-good neurotransmitter. Research has shown that tyrosine can help reduce cravings for alcohol and cocaine as a result. It's a suppressor, as a precursor to dopamine, it supplies the reward and anti-craving effects, which is what dopamine does, and it helps to fight stress. Now tryptophan, we've got here as the feel-good factor, converts into serotonin via the 5-hydroxytryptophan pathway, which we'll look at a little bit later. So it converts to serotonin, and so lifts depression and restores emotional equilibrium. Serotonin is a restorer of feeling normal, okay? So when you don't have serotonin, you feel low, and that low is called the blues. Now we know that each meridian is stimulated by a different color. We've met that before in our muscle testing. And the color for serotonin associated with the bladder meridian is violet. And what we know is at this time of the year, which is November here, the sun is lower than 45 degrees. And gradually as we get to midwinter, it gets lower and lower. So you get less of the violet end of the spectrum, but you get a higher amount of the blue. And blue is a depressive compound, a depressive wavelength, rather than violet, which is a stimulatory one. So this is why it's called in the Northern Hemisphere the blues, because in the wintertime people get depressed, but the depression is called the blues. In other words, you just feel low. There's no other word for it. And people will tell you, that they're much better in the summer. And, they get this depression come in around the equinox for us and get steadily worse. Once they get to sort of January, February, they say, they can see the light is coming. And they feel better when they're in the light, but not indoors light, because that doesn't supply them the ultraviolet. And interesting, even the conservatory doesn't do it, because the conservatory takes out the ultraviolet. So there's a concept that serotonin, also that first pathway of making serotonin, is stimulated by vitamin D. So the question is, which actually makes you feel better? Is it the vitamin D, which helps to stimulate a lot of the enzymes that you get from the violet end of the spectrum? Or is it actually the serotonin itself, or both, or neither? So serotonin, what I want to make sure you understand, is not a happy pill. Sometimes people say, it's a happy chemical. It just brings you up to feeling as you should do, okay? So serotonin. So serotonin, like all chemicals in the body and all neurotransmitters, can be too low and it can be too high. When it's too high, it's associated with the kidney meridian, which is the opposite, if you like, to the bladder, the couple to the bladder. So serotonin tends to indicate, high serotonin is associated with the kidney meridian, low with the bladder meridian. So interestingly, low levels of serotonin is more feeling down, feeling depression, blues, and then you go over the top of the bell curve, and when you go on the other side of that, you go into anxiety, or more stressful. So the kidneys are associated with anxieties and stress. So at that time when you go over and you get too much serotonin, it can go over the top now. That's why I call serotonin the gin of the neurotransmitters, because if you have a little gin, you feel better. If you have too much gin, you go the other way and start feeling anxious and depressed. So converting serotonin lifts the, from tryptophan, if it's converted to serotonin, lifts feeling this low feeling of depression. It's the single most studied nutrient in psychiatric community, most of which has been found by accident. We're treating animals for different diseases, different conditions, and trying different experiments, often for totally different reasons, with chemicals on animals and noticing what happens. And if they calm down or if they get anxious and so on, they observe very much the animal and they think, oh, I wonder if that works in human beings. And that's how they discovered most of the antidepressants and tranquilizers back in the 1950s and 60s. They really don't know how they work. They can't be sure whether these things do increase serotonin. But nowadays, the more modern drugs we know block the breakdown of serotonin. So they inhibit the reuptake of serotonin. So in other words, you don't start to recycle and break it down. So you leave serotonin in the synapse, and then the person thinks, or the nerve thinks, oh, you've got serotonin, and it continues to fire. The problem with this approach is after a period of time, the body adapts to that and says, we don't need to make it because somebody else is making it. And it actually goes in the reverse way. And this is the problem, that people who go on selective serotonin uptake inhibitors can feel better after a while, and then all of a sudden, and that's when you get these sudden, particularly youngsters, commit suicide. Because when you get no serotonin produced, you go right down into the blues. And this is the problem as a side effect, because the body adapts to it. It does it after a period of producing or thinking there's enough serotonin there, so the mechanism switches off, and then suddenly, wham, you've got none of it. And the concept of putting youngsters on antidepressants is awful, and they're trying to increase that rather than decrease it. They're trying to actually encourage youngsters to come forward and say, I've got a mental illness, I feel depressed because of my life and everything else, and they put on these antidepressant drugs. So serotonin itself will go on through a couple more pathways to produce melatonin in the pineal gland and other tissues in the body, which helps us to sleep. So tryptophan could be a precursor to making serotonin and ultimately melatonin now. Serotonin helps to dampen the cravings for carbohydrates. It inhibits insulin release, and thus helping to raise blood sugar. And it's more of a calming than a stimulatory effect, as I said. The halfway compound, the intermediate compound of converting tryptophan into serotonin is called 5-hydroxytryptophan, or 5-HTP. Is a naturally occurring amino acid and chemical precursor, as well as a metabolic intermediate in the biosynthesis of serotonin. So sometimes, if the person strengthens, let's say, to 5-hydroxytryptophan and weakens to tryptophan, then it's that hydroxylation pathway which is inhibited. So you may consider, certainly in the short term, of prescribing 5-HTP. I've found this can be very effective also as a pain reliever. People who've got sort of intractable pain, 5-HTP, because it may be that they feel very low, particularly if they've got a very serious illness. It can help them cope. So 5-HTP can act as a painkiller. So here we see tryptophan, here we see 5-hydroxytryptophan and serotonin. So this pathway of the hydroxylase enzyme and the decarboxylase is the same with making dopamine from tyrosine. It's the same enzymes, and that's why we call it tyrosine hydroxylase. and dopamine decarboxylase is actually the same enzyme as in tryptophan. Now the first pathway here, we'll see here, is stimulated by vitamin D. So this is why vitamin D helps people feel better during the winter. You know, it's because it helps to produce serotonin with people. So you notice, like where there's anything that's good, that stimulates an enzyme, there's also something that's bad. And we see here that it's inhibited by cobalt and DDT, which is still around a lot. Manganese, nickel, and high levels of zinc can inhibit this pathway. So the decarboxylation, all decarboxylation pathways require pyridoxal 5-phosphate. So this is why P5P helps people with almost all brain chemicals. Hormones have P5P somewhere in there. There's not a chemical, I don't think, in the hormones or brain chemicals that doesn't use P5P in its synthesis or metabolism. So it's called the anti-stress vitamin, isn't it, pyridoxal 5-phosphate. Okay, so a summary of the 20 amino acids functions. Sulfur group, methionine, cysteine, and taurine. So we'll come back to those because they're involved with methylation, detoxification, and taurine, particularly with the brain, the bile production in the gallbladder, the eye, and stress because it's an inhibitory neurotransmitter. The urea cycle, amino acids, is arginine, along with citrulline and ornithine, which are less essential ones, but nonetheless important there. They produce nitric oxide, they get rid of ammonia, that's the main thing. The glutamate group are involved with excitation in the brain, it keeps us going there. Asparagine and aspartate with energy, and proline goes on as a constituent of collagen. The threonine group are the immune system builders, so we've got the immune booster with threonine. Glycine is the main constituent of collagen. Serine with phosphatidylserine is involved with memory, and alanine helps us with low blood sugars. The branched chain amino acids, these are the ones that prevent sarcopenia or loss of muscle mass, so it's leucine, isoleucine, and valine. Lysine helps us boost the immune system as well as threonine there, and particularly with herpes simplex virus. Lysine again is a constituent of collagen and carnitine. Histidine goes on to make histamine and helps us also with fighting inflammatory joint diseases. Just finishing off the section on amino acids here individually, Dr. Goodhart said, use branched chain amino acids an hour before aerobic exercise, about 3 milligrams per kilo body weight. And the reason for this is interesting because cortisol, which is a glucocorticoid hormone produced by the adrenal cortex, has 2 periods in the day when it's higher than at other times. And the first period is about 4 till 6 in the morning. Okay, basically between 4 and 6 a.m. we get a spike and up. Then it tails back down to a normal level, and then we get the same in the afternoon, 4 till 6-ish in the afternoon, when you get a slight increase, not as much as in the morning. So you get that spike in the morning, usually hopefully when you're asleep, because you've gone perhaps 8 hours since eating. So what happens is your blood glucose level drops down while you're asleep. Okay? And when it reaches a critical point, cortisol will kick in and elevate it by mobilizing, in this case, proteins. So you get a build-up, an increase of the cortisol in the middle of the night. Otherwise, what would wake up is you would wake up in the hours of the morning when you get up, and you would feel dreadful. So people who've got burnt out adrenal glands or hypoadrenia wake up and they feel foul in the morning because they got low blood sugar. And when low blood sugar hits the head, which uses more glucose or produces more energy than any other tissue in the body, it doesn't function properly. So they get dizzy, they fall over, they feel faint, they're in a foul mood, they can't think straight. and they're very, very argumentative. You want to stand back from people like this in the morning, and because until they've had a couple of cups of coffee and several cigarettes and things, they're not worth talking to because they're evil in the morning. And the reason for that, they need to be stressed to hit their adrenals, okay? And when they've had a good argument or stressed the adrenals, their cortisol level goes up and then their blood sugar comes back up. Or the quick fix, of course, is to have something with sugar in it, which gives them the quick fix, but then, of course, the insulin comes in and drops it back down again. So hypoglycemia is usually a sign of burnt out or low levels of adrenal function. So that's the normal why we have a surge in cortisol at 4 till 6 in the morning. So you don't wake up like that. So you've built your blood glucose levels up at that time. And it's the same in the afternoon, that you find 3 hours after lunch, your blood sugar level, because you're awake, you're using more blood glucose anyway, so you need that little peak. And that's why people have an afternoon tea. Usually afternoon tea is a cup of tea or something, and sometimes just a little sandwich, a little bread and cucumber, something like that. Very thin cucumber, and a piece of bread or a biscuit, something like that, just keeps you going. Because I spot it here by 4 o'clock in the afternoon, I can see who's getting into a hypo, or they're dropping off. If they drop off immediately after lunch, it's usually something they've eaten for lunch. If it's a couple of hours afterwards, it's usually a blood sugar handling, that it's dropping. And this would be the sort of more adrenal exhausted type of people. Okay, now that's independent, that's normal. Those two increases in cortisol are part of the natural cycle of all hormones. So what we find when we do the hormone module is we can actually test this using muscle testing. Because a person shows high or low in a hormone, it might not be the same thing in the afternoon or the middle of the night. And it's real fun to do a graph out of, say, cortisol over the period of 24 hours. And you can do that with muscle testing by what Dr. Goodhart called the then and now technique. So you can change a person from now to whatever time of the 24-hour cycle you want, and then compare them with cortisol. So you can say, how do you like cortisol at 12 o'clock midday? How do you like it at 2 o'clock in the afternoon, and so on. So you can go through the different meridian in the body clock and find out whether the person strengthens or weakens. And you'll find then there's a time when, that certain hormones will be high, and maybe times when they hardly exist at all. For instance, you don't want adrenaline and things when you go to bed, do you? So if a person weakens to adrenaline at 10 o'clock, you know that they're going to bed stressed, and that's not a good idea. Now, what has been found is that if you exercise a little bit later, between 7 and 9, that should be, so that's 7 to 9 a.m. and also 7 to 9 p.m., you will actually produce a greater amount of cortisol. So there must be some reason, again, cyclical for this. So if you exercise at other times, it doesn't do it. I'll correct that in a minute. So it's between 7 and 9 in the morning and 7 and 9 in the evening. And this is a danger time to do exercise, particularly aerobic exercise, because you get this surge, greater surge in cortisol, which is interesting. This is something well known in the sports world, is you don't start training sports people until 10 o'clock in the morning. When you see footballers, they don't start at 7 o'clock in the morning. They go out at 10 o'clock, and you think, oh, lazy devils. But there's a sensible reason for this, and the reason is you get this surge in cortisol. And if their level of their blood sugar is not right, what will happen is they'll start to strip their branched chain amino acids from the muscles, and they get muscle injuries. So if you're stripping your hamstrings of leucine, isoleucine, and valine, you're more likely to get a tissue injury. So if you're a person who exercises, and you have to exercise between these times, which some people have to because it's before you go to work and when you come back from work, and you find you keep getting a shoulder injury or hamstring keeps going, that's a good time to take branched chain amino acids before you exercise. So what Dr. Goodhart found is an hour before, so you get these free-form amino acids in the three components. In other words, the leucine, isoleucine, and valine, ideally at the ratio of 2 of leucine to 1 of valine and 1 of isoleucine, an hour before you exercise. Okay? That way, you're more likely to have a level of those 3 amino acids in your pool, in other words, in your blood, that if you need cortisol, it'll take those and it'll burn those and put them through the gluconeogenesis. So it makes sense, you know, to take a few hundred milligrams of those before you exercise if you're prone to injuries. If you're not prone to injuries, it probably is okay. It's not a problem with you. But if you're just, most sports people are perfectionists. They don't want 100% out of their body. They want 200% out of the body if they can, which means they're stressing themselves all the time, which means the adrenals are kicking in, you know, most of the time when they're playing. So do not exercise at these times without branched chain amino acid supports. The aromatic amino acids, again, summary of their functions. Phenylalanine, think about perhaps endorphins, enkephalins, pain relieving. Tyrosine, think about thyroid and also stimulating dopamine. And tryptophan brings you up to feeling normal or feel good factor. Now, of the amino acids, histidine, isoleucine, leucine, lysine, methionine, phenylalanine, threonine, tryptophan and valine. 2, 4, 6, 7, 8, 9, isn't it? So 9 of them are counted as essential. That means we have to get these from the diet. You can't make these from another amino acid. Right? So 9 of those. The other ones can be made from the essential ones. So these are called, therefore, non-essential. So alanine, arginine is one of those iffy ones. In some species, it's essential because, if you remember, they wee ammonia, okay? Whereas we wee urea. So it's not an essential amino acid. We make it from citrulline spinning the urea cycle. But in most species, they don't, and therefore arginine is an essential amino acid for building proteins. They have to get it from their diet. They can't make it. Asparagine, aspartic acid, cysteine, glutamic acid, glutamine, protein, glycine, serine, tyrosine, and taurine. These are all non-essential amino acids. So here's another chart of them.